So let's talk about functions. This is the first unit or the first section in our new unit on linear functions. And so I'm going to take advantage of the fact I can really zoom in lower so you can see. Okay, so the first thing we're going to do is we're going to talk about what a domain and a range are. Okay, so domain and range have to deal with things when you relate two things together. We call that a relation. Okay, so here we go. Let's begin. Juan, close up the book. Let's do this right now. Okay, so a domain. Domain, we're going to call this all the possible inputs. And when we have a coordinate plane, it's the x values. Okay, so if I have a coordinate plane, you know how we have an ordered pair? So if I have a xy ordered pair, the domain has to deal with the x values. So for us and a good chunk of the time, until you get into really advanced math, we're always going to think of the domain as all the x values. Okay? So a couple of things we want to highlight here. We want to highlight the fact that we have inputs, and we always associate those with the x values. All right? Now, so that's a domain, pretty much our x values. We're also going to deal with, if there's a domain, there's going to be a range. And the range is all the possible outputs. So those are going to be the y values. So in our ordered pair, where we have xy ordered pair, the domain is going to be all the y values. I'm sorry, the range. It's going to be all of these guys. So the range is all the outputs, which we associate with the y values. So pretty much anytime you have ordered pairs, if you relate one number to another in some sort of way, you're going to have a domain and a range. Okay. So the first thing we're going to do is we have a couple of situations where we have ordered pairs. and we want to list the domain and the range. And so let's do that. Let's take a look at the domain first of all. Okay. I'll put the domain in a squiggly brackets here. So the domain, does it associate with the x values or the y values? X values. So it's these guys. That's our domain. Okay. So if we're listing our domain, and it doesn't have to be in numerical order. In other words, we don't have to go from least to greatest. You could just list them. So maybe I would just do that. 8. Then we got 2. Then a 6. Then a -1. -10. Okay. That's a domain. Now the range is going to be all the possible outputs or white values. So that's going to be these guys. So let's list those. Now we got to be careful. We got -5, 1, 2, 6. But do you see how 1 comes up again? We only need to list it once. So even though it's twice in as a possible output, we only list it once. So we'll just stop there. We don't need to write 1 twice. Okay? So that's our domain and that's our range. Okay? Any questions? All right. So let's take a look at the second one then. What do we got in the second one? We got a coordinate plane. And we got some points on this coordinate plane. So we need to list the domain and the range here. Any thoughts on how we can do that? Yes, Jesse.
We look at each point and see where it is on our x value across the horizontal first, and then after we list where all we've got our range, we go to our y values for our range.
Yeah, we could do it that way. I would agree. So we can like write down each coordinate, or we can just see, okay, let's start with the domain. Let's start with a domain. So Jesse, tell me if this was your thought process. So we know that the x coordinate is on the horizontal. It's here. This is our x-axis, right? So we need to look at each point and see where it is on there. Right? We got one there. What number is that? So -2 is part of our domain. And let's just kind of work our way across left to right. Which other point? We got this point here, and it's so -1 would be another one. And then 1, because we got a point there. Oh, it's 0, sorry. It's 0. Yes, I was looking at the 1, but it's at 0. Okay, then where else do we have a point? Oh, 3. At 3. 4 and 5. Okay. So those are all numbers on the domain. Now for the range, we're looking at the y-axis. The y-axis is vertical, right? It goes straight up and down. It's vertical. So let's just kind of work our way on this one. We'll go from the bottom all the way up to the top. So let's see. First we have -5. So this is for our range. And then we have -2. What else do we have? -1 right there. One. There's 2 of them at 1, but we only list it once, remember? So even though there's 2 points, 2 dots, we only list it once. And then there's one last point. 3. So there's our range. It's a pretty interesting looking design there. Any questions so far? So domain and range are just looking for your x values and your y values. Yeah. Now, every relation has a domain, but not every relation is a function. Only certain special relations between an x and a y value, an input and an output, are functions. So in the next part, we're going to learn what a function is. Are you guys ready? Okay, let's talk about what a function is. Function. Okay. So in this section, we're going to write down what a function is. So here we go. A function is a relation between inputs and outputs such that, I love saying that word, such that every input can only have one output. So go ahead and write that down. A function is a relation between inputs and outputs such that every input can only have one output. And it doesn't seem like a lot, and it seems like, what does that really mean? But it's a powerful statement. Let's translate that into our language of x's and y's. Instead of input, let's say x values, and instead of output, let's say y values. Okay? So if we're saying it that way, every x can only be associated or be with 1 y. Every x can only be with 1 y. And inevitably, because you're linking these up, hooking them up, it kind of, you get this kind of like dating analogy. Think about what we're saying. Think of x's as one type and y's as a different one. Every x can only be with 1 y. Seems simple, right? Every x can only be with 1 y. If this is x, it can only be with 1 y. Is the reverse true, though? Can every y only be with 1 x? No, we're not saying that. And we're going to see that over and over again, that output values will be linked with more than one input value, and that's going to be okay for a function. But if x ever cheats on y, that's no good. Okay? Just think about that. Okay, here we go. So every x can only be with 1 y. Just make that like your mantra for this. And the main thing, and the one way that makes sense usually for most of us is x's cannot cheat. But y's can. I'm not saying it's a fair world, it's in the world of functions. But it is what it is. Now, let's take a look. It says state the domain, range, and is the relation a function. So we're going to do what we did before. We're going to look and see, this is the domain, this is the range. And yes, it is a function, or no, it's not a function, based on this rule. Okay? So let's see here. First of all, let's just do the domain and range, because that's kind of easy. So what's the domain here? So it's 3, 0, and we already have 3 there, 13. 3, 0, and 13. Okay. Let's do the range. The range is the y's. So that's going to be 16, 6, 19, and 2. Okay. So now to the big question. So go ahead and write that down. Let's decide, is this relationship, because you're linking things up. You're linking 3 with 16. You're linking 0 with 6, etc. Yes, this is a function, or no, it's not a function. Remember what makes it a function. X's cannot cheat, but it's okay if y's do. Yes.
The 3.
What about 3?
I think it's the one cheating.
Oh, the 3 here? Okay, well, those are the only 3s. The only 3s here. So 3, do you guys see that 3 is cheating?
Yeah.
Here's why. 16 and 19 need to talk to each other here, because here's 3 with 16, and here's 3 with 19. So because of that, because 3 on the domain side is also associated with 2 numbers, we're going to say not a function. So not a function. Okay? All right. So the next three types of relation maps we're going to look at, these are called mappings. So you see the next three that we have here? These are called mappings. And they map something in the domain with something in the range. Okay? So let's start with listing the domain and range. Domain. This one's super easy because it's just 3, 20, 1, and 6. They even call it domain. On the range, we'll just quickly write that. -9, 19, -20, -9. So from what I can tell, nobody's cheating. So it was okay if the range values cheated, but I don't see that. So yes, it's a function, or no, it's not a function.
Yeah.
Yeah, this is a function. Okay, so especially when you got stuff like this, telling what's a function and what's not a function is usually pretty obvious and easy. Okay, so let's just move on to number 5. Domain. -13, 2, -13. Range. Oops, wrong color. -20, 18, 15, 3. Okay. What do you guys think? Yes, it's a function, or no, it's not a function? Who's cheating? 2. On these mappings, if you ever have something in the domain branching off to more than one, not a function. So this is what made it not a function. Okay? So that's not a function. All right, let's move on to number 6. Let's see, we've got a domain. Wow, we got a lot here. 1, 9, 13, -4, and 2. And the range is only 3 values. -17, 12, and 4. Okay. Is there cheating?
No. Well, technically there is.
Technically, well, there no. Technically, there is cheating.
There's one with the line. It's with
Yeah.
the line, so it's fine.
17 and 4. Look at that.
It's okay if they look right.
It's okay if they cheat in the world of functions, right? Yeah, 12. Oh my gosh, the conversations we start because of this. Okay, the 17, obviously, there's 2 domain values. What is it? 1 and -4 to 17. And then we have 9 and 13 to 4 in the range. Is it a function though? Yes. This is okay. This is okay, and this is okay because it's on the range side. So this is a function. Okay. So what we don't want to see is multiple branches on the domain side. What's okay if it happens is, multiple branches going to one range value. Okay. Now, so the last thing we're going to do, guys, we're going to look at graphs, continuous graphs. So whenever you look at graphs like these, some of them are functions, some of them are not. And the easiest and quickest way to tell is by performing what's called the vertical line test. All right. And it's very easy. So here's how it works. So the vertical line test is a method that is used to determine whether a given relation of a graph is a function or not. And here's how you do it. If you can draw, notice how that's worded, if you can draw a vertical line that touches the graph more than once, and here's the payoff, then it's not a function. In other words, if I am able to, at somewhere within that graph, draw a vertical line, a straight up and down line that hits that graph multiple times, 2 or more, then that graph isn't a function, because that means you have an x value going to more than 2 y values. So let's just take a look at this first graph. It looks like a sideways absolute value graph. Okay, so just by quick observation, is there a location where you draw a vertical line that would touch the graph more than once? Yeah, there's a bunch of them. Pick your point anywhere in here. And I'm just using the ruler to show you anywhere in there exists a line. A line can be drawn, and it touches, in this case, 2 times. So not a function. The reason being is at this x value, you would have 2 y values. Okay, so it's not a function. Let's look at the next one over, this sideways parabola looking thing. Function or not a function? Not a function. Almost everywhere that would happen. Okay. And so, by the way, everyone knows that you see the little arrows. That just tells you that it continues in that direction infinitely. So on this side, it's just going to kind of go down forever. On this side, it's just going to go up forever. So the only interesting stuff for this graph happens right around here. So is there a location where I can draw a vertical line that would touch more than one time? Nowhere. I'll just draw one. It only touches once, and anywhere on the graph it only touches once. So is a function. Okay. All right. Take a look at the next one. Totally not a function.
Literally an X.
1, 2, 3. So the sideways cubic graph is not a function. Okay. All right. So here's another not a function. Okay. Now this next graph, you see this dashed line? That line has the unfortunate name of being called an asymptote. Yeah, it's called an asymptote. And what it is, I know, I got a chuckle out of it when my teacher first told me about it. So what it is, it's a boundary. This curve will never reach. It will get infinitely close to this dotted line, but never reach it. So it's going to get as close as you would ever want. At infinity, wherever that exists, this line would actually touch that line, but infinity doesn't exist, so we won't even deal with it. So this curve just goes down, 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 never reaching that dotted line, okay? And in this direction, it's just going to go like that. So yes, it's a function, or no, it's not a function. It is a function. It is a function. Because anywhere you draw a vertical line, yeah. So is a function in this case. Okay, and over here we have an ellipse. Ellipse is like an oval, not a function. There are only two locations at the endpoints here that a vertical line would touch once. Everywhere else it touches 2 times. So not a function. And the last one is a proper cubic function, or I just gave it away, is a proper cubic relation. So if you ever wondered what would happen if I had y equals x to the 3rd power, it would make a curve like this. Okay? And anywhere you go, it's touching only once. So it is a function. Is a function. All right. So basically, that's what we're doing on the 3 IXLs that I have for you. They are super easy. Honestly, if you absorb this material, it should take you maybe a minute or two to do each one. We got a little bit of time, so let's get to it.